Module 5.2, Day 1, Multiplying Polynomial Expression. Content Standard. Understand that polynomials form a system analog to the integers and are closed under the operation of addition, subtraction, multiplication, and division. Language objective. Student will be able to explain to a partner what FOIL means and how to use FOIL method to multiply two binomials. Example 1. Multiplying binomials using the distributive property. To multiply a binomial by a binomial, the distributive property must be applied more than once. Example 1. Multiplying using the distributive property. So example 1a, we have a binomial x plus 5 times the binomial x plus 2. So we're using the distributive property. That means that we're going to take this x, we're going to multiply into every one of these. So then we say that this is x times x plus 2 plus, because of the plus sign, 5 times x plus 2. So this gives us x squared plus 2x, and then this gives us a 5x plus 10, and then a combined like term, so this gives us an x squared plus 7x plus a 10. Example B, we have a binomial times a binomial, right? So this gives us 2x times x plus 3 plus 4 times an x plus 3, and now using distributive properties, so give us 2x squared plus a 6x. Distributive property, this gives us a 4x plus a 12, and then now we're combining like terms, so it gives us 2x squared plus 10x plus a 12. Okay, so then we can see that a binomial times a binomial will give us a trinomial, right? But it's not always a trinomial. Okay? Right, so this is your turn, so can we try out number 3? Okay, so the answer will be x squared minus x minus 2. Right, example 2. Multiplying binomials using FOIL. Another way to use distributive property is the FOIL method. The FOIL method uses the distributive property to multiply terms of binomials in this order: first term, outer term, inner term, and last term. So multiply by using the FOIL method. So here we're taking these two and then these two. Right? So we have x squared times x plus x squared times 2, and then the other term we said 3x plus 3 times 2. So when we work this out, this gives us x cubed plus 2x squared plus that 3x plus 6, and there's nothing to combine, so then our answer would be x cubed plus 2x squared plus 3x plus 6. So then we see from this example is that we have a degree 2 binomial times a degree 1 binomial. We have a degree 3 four-term polynomial. Okay, so let's try example B using the FOIL method. So we're using these, right, and then the inner last. So we have 3x squared times x plus 3x squared times 5 minus the 2x times x minus the 2x times 5. So it gives us 3x to the third power plus 15x squared minus 2x squared minus 10x. And these two are the same. We can combine those. We have a 3x cubed plus 13x squared minus 10x. Okay, so here in this example, we have a degree 2 binomial times a degree 1 binomial, and the result is a degree 3 trinomial. Okay, and when we write answer, always write it in a standard form. Right, so now this is your turn, so can you guys try out number 6? Okay, so then our answer will be x cubed plus 6x squared plus 3x plus 18. Right, so can we guys try this out? Right, so you may use the distributive property or the FOIL method. Okay, let's go on to number 7. Okay, and number 8. Okay, and for number 9, you can notice that we have the G on the right hand side. Right, if you want to, you can change it into a standard form, or you can use FOIL and then at the end change it back to a standard form. Okay, and then now write it in standard form. So we have a negative 40g squared. Combine like terms to give us a positive 3g and a positive 20. Okay, number 10. Okay, so from 10 we write R before S. Okay, and for number 12, we have 25 minus 5x plus the 5x minus x squared, so these cancel out. So write it in the standard form, so we have a negative x squared plus 25. Okay, so now for number 19 and 20, we have a binomial times a second degree trinomial. Right, so similar to a FOIL method, the first term and the inner terms. So this gives us x times x squared plus x times 3x plus x times 5, and then 4 times x squared plus 4 times 3x plus 4 times 5, and then this gives us x cubed plus 3x squared plus 5x, and this gives us a 4x squared plus a 12x plus a 20. And from there, combining like terms will give us x cubed plus 7x squared plus 17x plus a 20. Right, and so here we can do this. Right, so we can use the mental math to do the to do the product. So it gives us 3m squared minus 3m cubed minus 3m squared plus 15m, and 4m squared minus 12m plus a 20. And from there, combine like terms, so 3m cubed minus 5m squared plus 3m plus a 20. Right, so that's the end of our notes for 15.2 day 1. You have your book set assignment, you have your new HRW assignment, and copy down 5.2 day 2 notes.